So here exactly is what we have. What I want to discuss is not really my project, but a project that I'm encounter and I really love it. I really love it. And I don't really just, give it to anybody as a suggestion. I think this is a must. This is a must, especially for anybody who are running on blockchain. And you could just have one of your node, and I know have multiple nodes on your setup at home. Just use one of your node. I run it on my MacBook Pro. Of course, you can actually use it on your computer, and you just use one of your nodes to actually run it. It will automatically compute the mathematic formulas or you say the mathematical models on your computer, and once you view that, you will have this wonderful animation in 3D that actually shows you exactly what you compute, the progress of your computation, the core that is actually using while it's assigned to, the running, of course, your name and your team. It's a Stanford project, a School of Medicine project, but in actuality, I think this should be a distributive computational project because it involves with a nice to look at the GUI. It involves a good disclaimer, a good about page. It gives you a help screen, shows you exactly how it works, which is really interesting because now you can actually, and you also use OpenGL to actually do the GUI, which is really nice looking. I always like OpenGL and how much more you can actually do with it, although OpenGL is actually really complicated. And this is not is this for a beginner? Yeah, this is for a beginner who wants to run, because it's much easier to run than any distributive computational project I know, and you actually helping the progress. And as you can see, these type of projects, their computational power is already exceeding a supercomputer that we were talking about. Well, if you get into a technicality, you need to go to their webpage and see which supercomputer they actually exceed. But as far as I know, is helping whatever you do. You use a distributed computational, use a distributed computing to distribute many formulas, partially part of the formulas into your working unit, and anybody just needs to compute a single working unit. And once you compute a single working unit, you will get the running stats. As you can see, I almost finished. Is 97.19%, which is brilliant, which is really brilliant. The CPU, of course, there are points per day, so that if you want to get really technical, you can have a board to actually compare the results, which is really neat. I love it. System log. Now this is the technical stuff. There's things in the Git that we can actually get. We could try to get the log, which shows you exactly what steps it does, shows whatever it's reading, and hopefully it doesn't really record any of the information. But it is really interesting. It is really cool. The configuration preference is nothing new, but it needs 2 days to actually progress this current working unit. It's really similar to Bitcoin. Well, I mean, the final product is really similar to Bitcoin, but the underlying methodology, if I really need to compare, is really similar to Ethereum, if you actually know how Ethereum generally work, or US, if you want to know how US generally work. But aside from that, is really just, it's really similar to OpenGL projects plus a distributed projects. And I want to show you is that they actually managed to use a JS to actually connect from the web page to the to the client. Although I don't really know why this is not connecting successfully. As you can see, it's not successful. It's not reading properly. That's what I see. But it's definitely working. You see, here's the thing. We want to help. If you like technology, you like a serious technology, and you like a novel technology such as distributive computing. Because the other day they actually asked me about distributive computing in terms of edge computing and so forth. And I can talk a lot about edge computing, how it will change the world, how edge computing will go from here. But what I really want to focus on is that how health devices actually, interestingly, health devices actually also communicate with my own company. It's a big company that doesn't really do much innovation. But this is really interesting project. I think people need to know this, and they need to do things with it. And I'm trying to contribute into this project, not just contribute my computational power, but also trying to fix the code, optimize the code if I can. Read the code, understand the code, that's obvious. Understand the code as I can. Trying to seriously learn how this might affect us. That's a second. And thirdly is that how to do a similar project, how to build a similar project from scratch. I think that's important. The code is actually written in Python, from what I know, right? And it's doing the downloading and running, right? It takes units and into queues. So I imagine it's more like a traditional parallel computing where you have work units, you have work and put work unit into queues and using the queues to actually prioritize which unit is working first. But let's see, we'll see how it works. But that's that.